Hey guys, this is a video over ionic covalent bonding. Some of you have emailed me. I'm recording this Wednesday night, that you're having trouble on editing some of the documents online. A couple people have turned them in, so some people have access to editing them on the Chromebooks. If you will email me, I know a couple of you emailed me late, and I've tried to get a hold of you and try to send you some Facebook requests and stuff, and send you some emails and try to do a Zoom meeting. So email me when you watch this sometimes that you're available, or I can set up a Zoom meeting. And what you'll get an email, and it'll have a blue hyperlink that you should be able to click on, and you can talk to me directly, or we can maybe do a video phone call through Messenger or through Google Hangouts, because I'm more than willing to help you. I just have to figure out how to get a hold of you. So when we do ionic bonding or covalent bonding, we basically start out diagramming atoms, and we're going to look at which electrons are going to be transferred or shared in order to stabilize the atoms. Now, generally with ionic bonding, that occurs between your metals and your nonmetals. Basically, your covalent bonding occurs within the nonmetal groupings. So the first one we're going to start with is ionic bonding. You have to have information from the periodic table, which I generally try to put on your handouts and stuff. So I'm going to switch to this here. So I'm going to pick two elements to do this with. So I'm going to start with lithium and chlorine. I've been drawing some there already. So for lithium, it has a 3 up here for 3. The atomic number is 3, which means it has 3 protons or 3 electrons. And the number down here is 6.9, which that rounds to 7. And remember that when we subtract the atomic number from the atomic weight, that gives us the number of neutrons. And that allows us to go ahead and draw that particular atom. So lithium's going to have 3 protons, 4 neutrons, and 3 electrons. Remember, the first energy level can hold a maximum of 2. You always start with the innermost energy level first. So the 2 of the 3 electrons go there, and that means you have 1 electron out here. Remember that your electrons can hold a specific number. The energy levels can hold a specific number. This first energy level maxes out with 2 electrons. The second one maxes out with 8 electrons. And the third one maxes out with 18 electrons. But since lithium only has 3 electrons, we just put 2 and 1 there. Now let's combine it with chlorine. And chlorine has 17 for the atomic number, which means it has 17 protons or 17 electrons. Its atomic weight is 35.45, which means it's going to round down to 35. Remember, if it's 0.4 below, it goes down to 35. Okay, so the nucleus is going to have 17 protons, and when you take 17 away from 35, that's going to leave you with 18 neutrons. And remember that these circles go all the way around. I'm drawing half circles just to kind of clean up the page a little bit. And because I'm going to be dealing with this atom here, I'm going to draw chlorine's energy levels on this side, but remember they go all the way around. They're kind of like layers of the atmosphere wrapping around the Earth. So these energy levels are like Earth's atmospheric layers wrapping around the Earth, only they're wrapping around the nucleus of an atom. Because chlorine has 17 protons, that means it has 17 electrons, and we start with the energy level closest here, which we can put 2 electrons there. The next one fills up with 8. 8's the magic number. And 2 and 8 means that's 10, and I still have 7 more out here. Now, atoms will give away or take electrons to try and fill their outermost energy level or have 8. 8 is the magic number. 8 electrons is called an octet. And these atoms will give away electrons or take electrons to either fill their energy level to max it out or to have 8 there. And when you look at these 2 atoms here, there's not any electrons here. Remember, I just drew this shell to show you what the maximum number was. This is the outermost energy level. It has 1. It needs 7 to have 8. This atom's bigger. It has more protons. So the protons are positively charged and the electrons are negatively charged. So opposite charges attract. So this is a lot more protons. It has 17 over here. So it's going to hold on to its electrons a little bit more tightly than what lithium's going to, because lithium only has 3 protons or 3 positive charges. So it's unlikely that lithium's going to take away chlorine's 7 electrons. It's more likely that chlorine will take lithium's 1 electron and it will let it go, because then once that electron's gone, that energy level disappears. That energy level's only there because that electron's moving in that space. If there's nothing to move around in that area, then there's no energy level there. And that means that the first energy level is its highest energy level, and it is filled with 2 electrons, which stabilizes that atom. So right now, lithium has 3 protons, which means it has 3 positive charges. And it has 3 electrons, which means it has 3 negative charges. A +3 and a -3 equals 0, which means right now this atom's neutral. It has no overall positive or negative charges, no net gain positive, no net negative charge. Chlorine over here has 17 protons, 17 positive charges. It has 17 electrons or 17 negative charges. So right now it's neutral. They neither one have a negative or positive charge. But with ionic bonding, when they start moving electrons between them, you're going to have net charges developing. And an atom with a charge is called an ion. So you've already figured out that this 1 electron is going to move over here. And when that happens, that gives chlorine 8 electrons out here. It's stable. This one goes away. The highest energy level is the second one. It stabilizes it. But now when you count up the charges, this one still has 3 positive charges for the protons there. But when that electron moves, it only has 2 negative charges. Now that means that there's an overall charge of +1. So if you have $3 and you owe somebody $2, you still are $1 to the good. So this atom here now, when it loses its electron, has a +1 charge. Well, guess what? Chlorine still has its 17 positive charges from its protons, But now it has 2, 8, 10, 17, and one more. Now it has 18 negative charges because it has 18 electrons. Now it has an overall charge of -1. It has one more negative charge than a positive charge. So this becomes a -1 ion. So now you have a lithium +1 ion, you have a chlorine -1 ion, and opposite charges attract. So those two ions, which are just atoms with a charge, are going to pull together, and you're going to have a bond forming between lithium chloride, and you'll have lithium chloride then. Remember that an ion is an atom with a charge. And so when two ions pull together, you end up having an ionic bond between them. So that's pretty much the basis of an ionic bond. So what I'm going to do next is I'm going to have you try to edit a drawing that I'm going to put on a doc and load it to Google Classroom to see if you can fill it in to show what happens with ionic bonding with two different atoms. Okay, we're going to do that for Thursday, and I may push something out over the weekend for covalent bonding and then try to get everybody caught up. So I really need you all to email me if you need to talk to me so we can set up a time to get everyone caught up and straightened out this weekend over the ionic and covalent bonding so we can move on to some other stuff. All right. Thank you.